So actually, I just want to start my words with thanking Jeremy and Carl. I was actually a participant in CyberAuto 2016, and then I started my PhD afterwards, and now I'm a professor working in car security, so thanks big time for that. Go CyberAuto, and Cybertruck, and the other two that I've never heard of. Okay, so which button do I press? The green one? I'm really bad with tech. I shouldn't be in CS. Okay, so I'm going to be talking about Detroit today. So as you all know, vehicles are getting increasingly connected. So the data that's generated in a car in an hour is around 25 gigabytes in total. And if you just look at the CAN bus, it can be 200 megabytes. And the data connectivity is also going up. The number of cars equipped with a cellular connection, for example, for offloading data to a backend is going up every year. And with these two metrics going up, so is the potential for data monetization by third-party apps. And also this will lead to a boost in academic research, which Pivot platform is trying to solve by having a crowdsource effort for sharing data sets with researchers. So first of all, let's answer the question: who's collecting what data? Obviously, a lot of companies are in here mostly for data monetization and supporting their apps. OEMs are collecting data. BMW has this entire car data platform to collect customer data and share it with potential third-party applications. So does Mercedes. Insurance companies like Progressive and State Farm, they have been collecting data for a while in order to analyze your driving behavior and adjust your premiums. Other cellular manufacturers, cellular companies like Verizon, T-Mobile, they're doing it. Autonomy is another one. Android Automotive is getting big by the year. A lot of car makers are starting to use it, and they support third-party apps. There's a lot of data that cars generate. So this is from our Lubricant paper. We analyzed a bunch of DBCs from passenger vehicles and found that there's a bunch of data that is actually being broadcast on the CAN bus of a vehicle. So there's a lot of tools. Obviously, car makers and insurance companies, they have their commercial tools, but there's also a lot of academic tools like that researchers have worked on. But what is really the problem with those? It's threefold. The first problem is the data access is very limited because as you all know, CAN bus data semantics are proprietary and stored in DBC files that car makers do not disclose with us. And it's hard to find like DBC files out in the wild. The second thing is the ecosystem lock. A lot of these commercial, but also academic solutions, they kind of require the hardware that you got to use in order to collect that data. They do not really support a variety of tools. And the third thing is the accessibility. There is not a really convenient way to actually connect drivers with researchers where a researcher can say, I need that, and that data, and then a driver will collect, and this data will get collected, processed, and shared with the researcher or the collecting entity. So accessibility is another thing. So with these three key issues we're trying to solve with our solution called Detroit, which is an open source, vehicle agnostic, end-to-end framework, and you can find it on GitHub under this link. It consists of two repositories, a front end and a back end. And we're trying to solve these three issues. The first one, we integrate. We want basically to reverse engineer DBC files and by a crowdsourcing effort. So everybody who drives a car can collect data and can use a tool to automatically reverse engineer our data. We provide Lubricant as an example for that. This is one of our papers that can automatically reverse engineer DBC files. And basically everybody can collect data, reverse engineer DBC files, and share it with the community. And the second thing is we provide a very straightforward interface to connect third-party app developers with or researchers, right, with drivers, as we will see in the next slides. And we also allow a lot of different hardware dongles through a standardized vehicular hardware abstraction layer. So we do not assume that you have to use certain hardware for, in connection with Detroit. Anything supported, really. So I'm just going to share a couple screenshots from our Detroit tool. So this is an Android front end app. Apparently, this was my old car, Hyundai Elantra. It can be in the database, so it can actually pull the DBC for data translation. If it's not, we have to reverse engineer it. This is how we can see that this is in this picture. We run Lubricant actually on the data to reverse engineer and create the DBC file. We have a web end for in the back end for like the developers to register their apps and choose what data they're interested in, so drivers can share it with them, and then they can download the data in MATLAB and NumPy formats. And yeah, multiple hardware dongles. So these are the three we actually support right now. It's very easy to add the syntax of other hardware dongles as well. Yep, I would like to, this took us a while to actually get this, to implement this and to make sure it's working fine. So I would like to thank the developer team at the University of Michigan. And again, here's a GitHub link in case you're interested. Also feel free to talk to me today. Thank you very much. And yeah.